Welcome to Study Loop.
So in this problem, we are given a precipitation agent which is KOH, and we are given three solutions of three different compounds. They are calcium chloride, then we have ferrous nitrate, and magnesium bromide. So we'll have to find out how much KOH we need to form a precipitate with each solution. So to know that, first you have to know what will be the precipitate formed in each case. So since we have um, three anions in three cases, chloride, nitrate, and bromide, and as we know that most of the halides like chloride, bromide, and also most of the nitrites, they are soluble. That means this chloride, nitride, and bromides, they will not form the precipitate we are looking for. So the precipitates that will be formed are mostly the hydroxides of the metal ions here. So the calcium hydroxide, iron hydroxide, and magnesium hydroxide. So if we write a general formula for the precipitate form, that will be M for the metal and OH for the hydroxide ion. And here we can see that all the metal ion we have here has a charge of 2 plus. That means the formula for our precipitate will be MOH2, where M is the metal ion. And to find the minimum concentration of KOH or the hydroxide ion to form this precipitate, we need to know the reaction quotient for this for the hydroxide compound. So the reaction quotient for these compounds will be equal to concentration of M and concentration of OH minus, and for these two we'll have to put a square here. So this will be the general reaction quotient formula for each case. And then to know the minimum concentration of hydroxide ion or the KOH ion, KOH compound we need, we have to consider this reaction quotient equal to the KSP value for this for the hydroxide compounds in each case. And from this relation, we'll be easily able to find out the OH minus ion concentration or the required KOH concentration. So if we just rearrange this equation, we can write from here OH minus equal to KSP over the metal ion concentration, and we put a square root for this square here. So we have just simply rearranged this relation here, and this is the equation with which we can easily find out the required KOH concentration we need to form precipitate in each case. So in first case, we just need to know the KSP value for each hydroxide we are forming and the corresponding metal ion concentration. So in first case, we are reacting calcium chloride with KOH. That means the precipitate form will be calcium hydroxide. So the KSP value for calcium hydroxide is 4.68 times 10 to the power minus 6, and the so the concentration of Ca2 plus or the metal ion here is basically the concentration of the solution, which is 0.015 molar, So this is the concentration of the calcium chloride we are reacting with, and since from each calcium chloride we will have one calcium ion, that means the concentration of the calcium chloride is the concentration of the calcium ion here. So if you just plug in this value here and this value here, we'll see that the value for hydroxide ion concentration or our KOH concentration will be equal to 0.018 molar. So this is the minimum concentration of KOH we require to form precipitate with calcium chloride. Then with just using the same formula we can find out the second one. Again, our OH minus or the KOH concentration will be equal to the KSP value. So in second case, the compound form will be FeOH2, since we are reacting ferrous nitrate with KOH, and the KSP value for FeOH2 is 4.87 times 10 to the power minus 17, and the Fe2 plus ion concentration is, we are using 0.0025 molar ferrous nitrate. That means since from from each ferrous nitrate we will have one Fe2 plus ion, that means the Fe2 plus ion concentration will be equal to the ferrous nitrate concentration. So in the formula we have KSP value on top, 10 to the power minus 17, over the iron concentration 0.0025, and we put a square root here, and if we just solve this we will find the value as 1.4 times 10 to the power minus 7 molar. So this is the required KOH concentration to form precipitate in case of ferrous nitrate. And then finally in C, we are reacting with MgBr2, and we will react with its KOH, and the precipitate formed will be MgOH2, and the required concentration of OH minus or KOH will be equal to square root over the KSP value and the Mg2 plus concentration. So here the KSP value for this compound is 2.06 times 10 to the power minus 13. Okay, if we just so the KSP value is 2.06 times 10 to the power minus 13, and the value for Mg2 plus ion concentration is, since we are using a 0.0018 molar MgBr2, that means, and from one MgBr2 we are finding one Mg2 plus ion, that means this will be the concentration for Mg2 plus, that is 0.0018. And now if we just plug this value in here and the KSP value here, then we will have the required KOH concentration, which is 1.1 times 10 to the power minus 5 molar. So this is the required concentration of KOH to form a precipitate in the solution of MgBr2.